Hello, everyone. I hope everyone can hear me. Thank you all for coming. I am excited to see so many of you here today, and I'm happy to share what we at Solis Biodyne have been working on for some time. The newest addition to our growing portfolio of enzymes is the Solis Hot Start HiFi DNA polymerase and the kit that it comes in. So today I will be introducing well, first of all, talking a bit about HiFi polymerases and introducing what we have been working on and what it offers, what benefits it offers, etc. And if you have any questions, feel free to ask them either during the presentation. My colleague Bibe will can answer these if she can, as best as she can, in the chat. And I'll also take a look at the end of the presentation, and I will answer some questions as well. So feel free to ask. Hopefully we can answer all the questions. So let's dive in. Before getting into the specifics of Solis HiFi DNA polymerase, let's look at what even are high-fidelity polymerases or HiFi polymerases and how they are used. There are several families of prokaryotic and eukaryotic DNA polymerases, classified based on sequence homology and crystal structure. Almost all commercially available DNA polymerases fall into one of the polymerase families, either family A and family B. The most popular examples from each group would be the Taq polymerase and the BFU, originating from Parrhococcus furiosus. When talking about the core features of polymerases, they're all associated with three main activities. And these are the key features that differ between the family A and family B polymerases as well. There is the 5' to 3' polymerase activity that is responsible for the addition of a new nucleotide at the 3' end of the strand. And this primarily determines the speed. This activity determines the speed of the enzyme. There is the 5' to 3' exonuclease activity, the removal of nucleotides at the 5' end of the DNA molecule, and it has some physiological uses in the replication of DNA. However, we also use it for example, Taqman probes or hydrolysis probes in general. And finally, we have the 3' to 5' exonuclease activity or proofreading activity, which is the removal of nucleotides at the 3' end of a molecule, and this determines the accuracy or proofreading activity of a polymerase. So this is how it looks like. There's the polymerization activity, and this 3' to 5' proofreading activity kind of goes back and removes any nucleotides that seem to be added incorrectly. And then the synthesis continues. High-fidelity polymerases are usually the ones that are usually commercially available, all fall into the family B category. Their key features are that they are more accurate, and this is largely due to the 3', 5' exonuclease activity that is not very active in, or not active at all, in the Taq polymerases, and it is functional in these BFU type polymerases or family B type polymerases. However, they lack a 5' to 3' exonuclease domain that, as I mentioned, is utilized by Taqman probes in qPCR. Additionally, HiFi polymerases generally show higher processivity, allowing longer fragments to be synthesized, enabling them to be on the DNA template for a longer time. The widely available HiFi polymerases largely fall into two categories. One's based on the BFU DNA polymerase, such as our Solis HiFi, and others like Q5, Kappa HiFi, Fusion, etc., that is used in PCR-based applications. And there's also Phi29 type that has a strong strand displacement activity and is used in applications such as multiple displacement or rolling circle amplification. And these reactions happen at constant isothermal conditions. And these Phi29 type 1s HiFi polymerases are the ones usually employed on sequencing platforms themselves. And you don't do PCR with these. This is a bit of a background into what are HiFi polymerases and when talking about polymerase in general. Now let's look at a bit about why these are important. I think HiFi polymerases are increasingly more in demand. There's a growing field of various applications that need this one critical feature, which is more accurate amplification of DNA or high fidelity amplification or PCR. One of the largest of these is the sequencing of DNA and RNA, where the accuracy of DNA amplification relates directly into the quality of the data. Ever since the Human Genome Project, the need for sequencing and benefit gained from it has rapidly increased. It's technology that is similar to PCR in a way that it has enabled a wide array of other technologies, and demand for sequencing has steadily risen, with the projected market size increasing 5 times over the next 10 years. Along with this, the need for infrastructure, instruments, novel reagents to enable this growth and pushing these advances in this sector. In addition to sequencing, where HiFi polymerases are very heavily used both in library preparation or the platforms themselves, there are other applications where high accuracy PCR is critical. For example, when cloning sequences using PCR, this is in any kind of cloning work where you need to be sure that what you cloned is accurate, or when you're working on mutations. Depending on the exact application, having a mutation in a sequence can range from being annoying to being critically important, meaning that you might need to repeat experiments. And these applications include cloning, protein expression, CRISPR-Cas workflows, site-directed mutagenesis that looks at concrete mutations, and having the exact sequence is critical. Additionally, HiFi polymerases are often used when regular PCR fails in the lab. Either the amplicon is too long or has difficult to amplify structure. HiFi polymerases are often better equipped as they're slightly different and work slightly differently compared to DAC polymerases, for example. As researchers and companies push for newer technologies and innovative solutions, the core properties of the enzymes and proteins used in these applications need to keep up with this and be similarly pushed to new limits. And this is something that we at Solis always try to keep in mind when we engineer and come up with new solutions for our proteins and enzymes. With this, I'm happy to introduce our newest DNA polymerase, Solis Hot Start HiFi DNA polymerase. It's an in silico designed polymerase with enhanced processivity and proofreading capabilities, currently available in a 3-tube kit format, although we are planning on launching a master mix format on this quite soon as well. So if this is interesting to you, then keep your eyes on our social media for any announcements. So let's look at some of the core features and properties of the enzyme and what it can offer. So some of the core features that make Solis Hot Start HiFi DNA polymerase different to our existing polymerases like Firepool or SolisFast, and also from other HiFi enzymes. I'd say the key feature is the increased fidelity due to the 3' to 5' proofreading activity that this polymerase has about 100 times higher fidelity compared to a DAC polymerase. However, it does not have 5' to 3' exonuclease activity as is standard for HiFi polymerases, and due to this, it cannot be used with hydrolysis probes. Our Solis HiFi also has increased processivity, meaning it can be used to amplify longer templates, and we have tested it up to 12 kb for complex, I think even higher now in recent tests, and up to 24 kb with some simple templates such as lambda DNA. It has a strong chemical hot start that increases specificity and allows accurate amplification of complex and highly multiplexed assays. Furthermore, we have made modifications to enable Solis HiFi to incorporate uracil nucleotides. Usually, HiFi polymerases are heavily inhibited by U-nucleotides, and this can cause issues, especially as there are some specific sequencing applications that require this, such as bisulfite sequencing. And of course, we have also incorporated our proprietary stability tag to the enzyme structure, meaning it can withstand elevated temperatures for long periods of time. When looking at in more detail at some of the features and the results, one of the issues with HiFi enzymes is that they are relatively fragile, even more so than Taq polymerases. And we have made genetic improvements to our Solis hot start HiFi DNA polymerase with the inclusion of a stability tag, meaning that Solis HiFi is stable at 25 degrees for at least 1 month without any change in performance and activity. And you can also see it demonstrated in one experiment here on the right, where the reference stored at -20 degrees and the test conditions stored in an incubator for 1 month at 25 degrees show no differences in their sensitivity, for example. This offers significant advantages in the convenience and unique uses for enzymes. You can set up reactions without ice. Shipping it is environmentally friendly, that we do in envelopes instead of using dry ice. And it's also good for any high throughput applications where the enzyme might stay out of the freezer for extended periods of time. Additionally, in our tests, we see good sensitivity with low DNA input amounts, which is as much as we compared is around or comparable to most of the competitors. As mentioned before, Solis HiFi has increased persistivity and it can amplify long DNA fragments. We haven't had anything in our portfolio that can achieve this very well previously. So I think this is a very good addition. Previously, a blend of some polymerases in our portfolio could do up to 5 kb, but here, this one, we can see that depending on the reaction conditions, it can efficiently amplify relatively long fragments of DNA, and you can do it in quite robust conditions. And there are many cases outside of just cloning as well, where this could be a very good and useful feature to have. One other feature that we are very pleased with is this polymerase's multiplexing capabilities. We have tested it in different conditions. Here you can see an experiment we did with 18-plex, where we saw that it can do it in very well in uniform manner for all targets. But we've also talked with some of our beta testers, etc. They've looked at this in different situations in library amplification, library preparation steps as well. And it can, we've seen that with some optimization, it can efficiently amplify very large or highly multiplexed assays. And we've seen that it's a relatively uniform coverage across all of these targets with some optimization. Mostly due to the enzyme amount here, you can see as well, it can improve the results with highly multiplexed reactions. Finally, Another very good feature of this is that it's versatile. It's a universal and uniform, and it can amplify targets with a wide range of GC content. We have had also good feedback from our beta testers who have tested this under challenging conditions, amplifying libraries from different bacterial genomes with varying content of GC, with good and even amplification of efficiency of all targets. On the right here, you can also see demonstration of Solis HiFi compared to some of the competitors when looking at targets ranging from 30 to 79% GC. Here is without additives for all of the enzymes tested, and here is with the appropriate additive as recommended by the manufacturer, and for us using the GC-rich enhancer. Another unique feature that I mentioned right in the beginning is the tolerance for eunucleotides. It's enabled by some modifications in the uracil binding pocket, and meaning that it can tolerate eunucleotides and also helps it tolerate damaged DNA. So this is a big research topic, studying the methylation of DNA, for example, in epigenetics. And one way of how epigenetics is studied is that DNA samples are treated with sodium bisulfite, which converts to unmethylated cytosine to unmethylated cytosine uracil, which is subsequently converted to thymine during the PCR amplification, while the methyl cytosine remains unchanged. Basically, it looks at where the methyl groups are on the DNA, but it does it through PCR that requires the PCR reagents to tolerate eunucleotides. And this has also been tested and verified by us and by some of our beta testers who used it in bisulfite sequencing to generate the libraries for bisulfite sequencing. But this feature also enables other uses, such as more efficient amplification of damaged DNA when working with formalin-fixed paraffin-embedded tissues, and also if you need to use carryover prevention in combination with UNG, for example. So yeah, this is this kind of takes in all of the core features of our Solis hot start HiFi DNA polymerase. To go over again, it has increased fidelity, as you would expect from a high-fidelity polymerase. It can amplify long fragments, up to 24 kb of simple targets. It offers broad multiplexing capabilities, great performance with both AT and GC-rich targets, efficient DUTP incorporation. Its stability is improved significantly 1 month at room temperature, and also depending on the request, we can also manufacture it in a glycerol-free variant. So if you're interested, check out our website or contact your contact at Solis Biodyne and ask for a free sample to try it out yourself. And that's it for me for introducing this product. So I'm happy to answer any questions that you might have. The speed of the enzyme, it is about 1 minute per kb extension. So it's not the fastest enzyme. It's similar to standard speed for enzymes. The glycerol-free variant is suitable for lyophilization. Yes. Well, for lyophilization, you would need excipients, which, depending on the situation, maybe we can provide, but you can also test them if you have any that you have, that if you have excipients that you're using, you can use these. But other than that, the enzyme part of it is compatible with lyophilization, yes. And you don't need to, I mean, you would need to still test it, how it works, but it is lyophilizable. That's a good question. I'm not sure if I understand correctly. Do you mean that is the incorporation of nucleotides equivalent with other nucleotides? I think we have not measured the fidelity of incorporation of nucleotides specifically, but we do have data on what kind of mistakes it does most commonly. And we can, if you need, we can possibly share this information as well. If you, does it change when substituting UFT? I imagine it shouldn't change, but maybe I will have to check the data on what kind of errors are the most common for this polymerase. The profile is quite similar to kappa HiFi, for example. And I think there are some published articles on what kind of errors kappa HiFi does. We haven't compiled a comprehensive report at the moment, but the profile looks quite similar. This is in the kit. We have the high-fidelity polymerase, DNA polymerase, Solis HiFi DNA polymerase. We have the reaction buffer, and we have GC-rich enhancer. It can be used in all directions, but it's mostly, it might decrease the efficiency of some AT-rich targets. But it's best, I mean, it's best used with GC-rich targets. So it's kind of an enhancer, an additive that you can add to your reactions to improve with performance with particularly challenging samples. And concerning the question about master mix, currently it's only available as an enzyme, standalone enzyme in a kit, but we are also working on making it into master mix format, and this will also be available soon, most likely within this year. It's already in a nearing prototype phase where it's getting ready. It should be. The hot start is covering, it covers the chemical hot start, how it functions. It covers very different parts of the enzyme, and I'm guessing that yes, the 3' to 5' exonuclease is also hot started, and it won't have any activity, so it won't chew up your primers. If you have any other questions, I'd be happy to answer them by email. If you email me, oliver.kare@solisbiodine.com, or our general email address, or you can come chat on our website with one of our support agents, or talk with your regional sales managers. So thank you. Thank you all for joining today. It was my pleasure to come and talk to you about our newest DNA polymerase, and I hope it was interesting for you as well to hear what we've been working on. Thank you all, and I guess I'll see you next time.